Hello and welcome. I'm Rob Ferguson, Marketing Manager here at Electro-Voice and Dynacord, and today we'll be talking about MTS, what we believe to be the next standard in large venue installations. Joining me today is Bob Reeder, our Global Product Manager, and Andy Pardo, our Engineering Manager.
Hi.
So to kick us off here, Bob, do you want to talk us through the MTS design concept?
Sure. Electro-Voice has a really broad portfolio for installed sound systems, and for sports systems in particular, we have a good match, ranging from small composite boxes that can be used in distributed systems. We have our EVF front load boxes and EVH full range horn load boxes that you'll find in baseball stadiums and in soccer fields around the world. And more recently, our line arrays have gone into NFL stadiums and World Cup soccer venues. But for about the last 10 years, there's been a gap in our offering for really large venues. And that is a box that has more output than EVH. So a really high output box with long throw, precise coverage, and the ability to cluster with other boxes and transition seamless between them. That is the gap that MTS is intended to fill. So we started this project maybe 2 years ago. We looked at the state of the art, we looked at what the competitive offerings were, and we talked to a lot of consultants and designers and integrators. In that process, we involved our engineering team from the get-go so they understood what the needs and the challenges were. And we came up with 4 goals for the MTS project. First one, not surprisingly, is just what's the output level need to be? So we crunched all the numbers in terms of how long people said they needed the sound to travel and what level it needed to be at the end of that throw. And the target we came up with was 150 dB peak, minimum. That was our threshold. Second goal was the coverage pattern. We decided that if we used fairly standard patterns, we would maximize the range of applications we would address. So we settled on 60 by 40 and 40 by 30, and further decided that our goal would be not just to have great response on axis, but to optimize the coverage throughout the entire rectangular coverage pattern. Third goal was driven by changes in what is demanded from sound systems in large venues. These days, it's required for much more than just speech reproduction. We know these systems are used to reproduce the full range of modern recorded music, and sometimes they're even the auxiliary system for a live concert. So we determined we really need full audio reproduction range from it, meaning going up to the end of the audio range on the high end, and on the low end, having enough extension and oomph so you could use the system in a satisfying way without a subwoofer. And then the fourth target had to do with complementing the control of the coverage pattern in the front by reducing the output of the speaker outside of that coverage pattern. So to that end, we decided that in addition to the 2 coverage patterns in a standard 3-way system, we would offer 2 more versions that incorporated an integrated cardioid section on the rear of the enclosure. So those were our 4 goals. And with those decided, my job was done. I just turned it over to Andy and his team to see how they were going to hit those targets.
Okay, so we've got the design targets. We've got greater than 150 dB SPL peak at 1 meter. So that's pretty high. We need full bandwidth response. We need concert level sound. And we need perfect dispersion. So how do we tackle that? Well, first of all, for your coverage and your dispersion control, you need as big a box and as big a horn as possible. You can't get too big because then nobody can install it. So we settled on a little over 1 meter by 1 meter, which is 43 inches squared. To get that accurate dispersion, we've used a constant directivity technology, so you can see the break in the horn here. And then to get these really, really high output levels, we had to use a coaxial compression driver, and there's actually 2 of those in this box on a manifold driving into the horn. The coaxial compression driver works really well because the HF section of it will go to very high frequencies, giving us that pure sound quality. And the mid-range section gives us very, very high output, but it also drives down to a lower frequency than a typical compression driver. So we cross over around 450 hertz with this box. And that means we can optimize the LF section to give that very high output as well, and to go down low enough so that we can get good bass response out of this speaker. So the port's tuned at 55 hertz. That gives us a useful response down to 50 hertz, which for most music reproduction is enough for this to play easily without a subwoofer. If you need that bottom octave for electronic dance music, drum and bass, or hard rock, then you can also add complementary subwoofers such as the X12128, which you'll notice is conveniently exactly the same size as it. To get that high output for the low frequency and the low mid frequencies, we've used 4 15-inch woofers mounted symmetrically on the horn and driving into the same horn. Because the HF and mid frequencies come out of the center in the back of the horn, and then the mid and the low frequencies then enter into the same horn, we get a true point source. And that means you've got this single coherent wavefront emanating from the loudspeaker, and that allows it to throw a really long distance.
Well, most of us are aware that EV has a long-standing history in sound reinforcement and fixed installations. Did we leverage any of that legacy or heritage in the development of this loudspeaker series?
Oh, we sure did. And that heritage goes back to the very early days of the company when Electro-Voice was located in Northwest Indiana near Notre Dame University. And at Notre Dame, there was a famous football coach who befriended the founders of the company and told them, he wanted a solution to the problem of having his players hear him during practices. He was tired of screaming. So they provided him with an early PA system. Now, this is the late 1920s when the term loudspeaker was not a household word, and in fact, the companies who were making devices like this didn't universally use it. So he loves his little PA system. He doesn't have to scream, but what does he call it? He called it his electric voice. So, in effect, a famous football coach named Electro-Voice. In the decades that followed, many of the technological innovations we've pursued have benefited sports venues and large venues. And those are things like driver developments that increase the output, things like the constant directivity waveguide that Andy already referred to. You can see the typical first and second flare of this profile. That's a technology that we pioneered. We have more experience probably than anyone else designing these. But 2 other technological innovations in particular were leveraged and sort of updated for the box. One is the manifold technology approach, where you combine the output of multiple drivers. And the other one is our Hydra waveguide technology, where we change the shape of the waveform. So both of those together were critical to the design.
Yeah, 3 products in Electro-Voice's history that really stood out to me over time. One was the MH horns, and these were well known for their very good directivity and extremely long throw. And that's what this box is all about. And then the other technology and product that stood out to me in the past was the MTL and the MTH system. And these were very high output concert touring boxes, which were the standard at the time. And what I wanted to do was I wanted to look at those technologies and see what we could learn from it and what we could bring into the modern design. Now, the MTL system has got 4 18-inch bass drivers driving it into an acoustic space, which then gives you the very high low frequency output. And this design, it kind of looks back at that because it's got the 4 15-inch drivers all driving into the same acoustic space and then out into the world to give us this very high output at low frequencies. The MTH had patented technology where they manifold multiple compression drivers onto a single channel that then goes to a waveguide. And that's pretty much what we've done here with the 2 compression drivers that feed into the channel and then feed the main horn of the MTS system. Bob mentioned the Hydra technology. That's what we call our wave shaping technology in waveguides. Now, I've got an example here, which is the current state of the art. This is what we have in our X1 and X2 line array speakers. Now, this is a line array waveguide. So what we're trying to do is we're trying to take a round source input, which would normally give us a spherically diverging wave, and we want to turn it into a plane wave line source output, which is what we need for a line array. So what we do here is we transform the wave by allowing it to just pass through the outer edges of this waveguide at normal speed, and then effectively we slow down the wave in the center by making it go around all of these pins, and that lines up to give you the ideal wavefront for a line array source. So we're doing a very similar thing here with the MTS, but instead of ending up with a line source, we end up with an arc source at the base of this horn. That allows us to have a square horn, even though we've got a 60 by 40 pattern. We set up the vertical dispersion by having the curve on the arc source setting up the vertical dispersion, and then because it's a thin arc source, you can then set the horizontal dispersion as you want it. The next challenge is really getting this huge amount of output. So we've got a compression driver, coaxial compression driver, and we're passing nearly 100 acoustic watts through the output of this compression driver. How do we then get that out into the world? Well, we designed a new version of the Hydra, and this does the same wavefront shaping, but instead of using pins and channels, it does it all purely by geometry. So you can see this curve here. This slows down the wave in the sensor. It allows a wave at the edge to go out in the standard time, and that sets up this arc source at the base of the horn here. To develop this, we use a finite element process, and we use the Bosch HPC supercomputing distributed computer system, and we can calculate what would normally take maybe up to a week in finite element calculations in about 2 hours. So that allows us to iterate the design and try many different geometries to arrive at the ideal design much more quickly than our competitors can.
Well, for a lot of large venue applications, including sports arenas and stadiums, we often see line arrays deployed. Is there any significant advantage with using a point source solution like MTS over a line array system?
Yes, I think two reasons you're increasingly seeing line arrays in stadium applications are, first of all, it's one way to get the output and get more output than you can get from available point source solutions. And the other one is the demand on sound quality in modern stadiums. But there are some challenges with line arrays as well. In order to get the output in the vertical directivity, that implies that you sometimes have to have quite a long array, because both of those design targets are dependent on the height of the array, therefore the number of elements. The more elements, the more amplifier channels you need, the more weight that's involved. In addition, a long hang can be pretty visually obtrusive, which means you have to hang it up high. That implies pretty extreme mounting angles. So there are some challenges, and a point source solution like MTS offers a really attractive alternative.
Yeah, so this one box will probably replace either 4 or 6 dual 8-inch line array elements, such as an XLD. And if you think about the line array being driven as bi or tri-amp, that's a lot of channels from your amplifier. This will be driven off just 2 channels from an IPX amplifier. We've got a 4 ohm low frequency, and we've got an easy to drive 6 ohm mid and high frequency. The 4 ohm low frequency can then be split into 2 8 ohm channels. So if you're hanging this in a large area where you've got very long cable runs, you can run 3 cable runs onto 8 ohm channels, and that means that your cable loss over a distance is much more reduced. You can then daisy chain these speakers at the end of that cable run with just a short extension, and it means that you don't need a home run cable from every single loudspeaker. This should really give a lot of value to the system's integrators, reducing time and cost and all of the other features that they want.
Well, another thing that was very much in our mind during the design of MTS was the amplifiers that we wanted to pair it with. We chose to really design to the capabilities of the IPX amplifiers from our sibling brand Dynacord. And that's particularly important because if you think about the output level of this loudspeaker, you really need to understand how the amplifier is going to behave at the limits of its output. And beyond that, you need quite a bit of sophisticated DSP to implement limiters and protective circuitry so you can ensure long-term reliability along with the high performance of the loudspeaker. In addition, that DSP capability came in very useful as we were working in the design phase to optimize the coverage.
Yeah, so as a speaker designer, I'm really happy to work with the IPX amplifiers because they give me everything that I need. I've got the analog output, so these are 150 volt rail amplifiers, the transducers and the system design is for 150 volts peak, so we can get the maximum output from a 10.4 IPX amplifier. The DSP capable amplifiers are exactly what I need as well. And what we've done on this loudspeaker, instead of just equalizing it to on axis, we take a measurement of the loudspeaker at every possible direction coming out of it at 2-degree increments. So we do a horizontal and vertical slice, and then we take all of the other in-between measurements as well. And when we're using the DSP, we don't just look at the on-axis, we look at every single one of these. And we typically look at it on a surface plot or a heat map. And we'll look at horizontal and vertical at first. And to get that minus 6 dB point to lie perfectly between the 40 or the 60 degree lines, we'll equalize that speaker with an emphasis on on-axis, but not fully controlled by that. So we can watch where the dispersion is getting wide or narrow, and we can use a DSP to control that. Once we've controlled the in-coverage response, we then start looking at, well, what's happening coming outside the coverage, and we want to minimize all of the sound that goes outside the coverage because that just reduces your STI and it reduces your dynamics and sound quality, and we're keeping that to the absolute maximum with the DSP.
Great. One thing you guys touched on a little earlier that I found pretty unique to what's offered in the competitive market is the fact that there are cardioid options within the range. You guys want to comment on that or give us a little more information?
Sure. That, again, was a response to what we were hearing very early in the interviews with designers and consultants. And the cardioid option addresses a couple of needs. The first is to reduce spill outside the intended pattern. Second is to clean up some of the intelligibility. And a side benefit is we get a little bump in the low end just where you want it if you aren't using a subwoofer. But the challenges of integrating that were also part of the design.
Yeah, well, once we design the horn and the geometry, we know we can go down to around 350 hertz with tight control, and then it starts widening out maybe up to about 90 degrees, 300, 200 hertz. So we add a cardioid section with a driver on either side. It's just the right distance to give you the right time delay so that you can do a full cardioid. Not only do you do the typical cardioid rejection of like minus 20 dB in the back for all the low frequencies, but we've tuned it so that just as the front horn starts losing its directivity at these lower frequencies, the cardioid then starts working, and it stops that from widening out any further than even at the very lowest frequencies, 120 degrees, and maybe at 200-300 hertz, we're talking about 90 degrees, and then you get the really tight control of the horn above 350 for the 60 hertz. So we truly do have a full bandwidth directivity device, and it's completely controlled. The less LF that we throw out the back of the speaker means that you're not bleeding sound out into the parking lot or annoying your neighbors or any of these kind of problems. But also, the less energy you put out the back, it means that in a more enclosed space, you're not putting all this low, mid, and LF energy into the reverberant field. You're improving your STI further, you're improving your dynamics and your sound quality as well.
So we talked a little bit about applications. Do we really feel there are other applications that we haven't touched on that we feel MTS will serve?
Yeah, we've been talking a lot about really big spaces and really high output. And in doing so, yes, the speaker can accommodate those, but we don't mean to imply that those are the only applications. It will scale to almost any size install. Many of the early inquiries we've been addressing have been for end-fire scoreboard systems where we're going to use 1 or 2 or maybe 4 of these. So in designing the box, we had to make sure that it could be installed easily, whether it's one box or a couple or a stadium full. And that was also part of the design.
Yeah, well, with an install box, it's very important that you can suspend the speaker simply and cleverly. One thing I remember from the customer interviews we did in the early stages is we had one guy from the south of the USA, and he says, I want to hang and bang and get on down the highway. And that kind of resounded with me throughout the design phase because, you know, this speaker will do the full frequency range. You put one up, it does everything for you. Well, you can mount this with just 4 M10 eye bolts and you can fly it and get the coverage that you want to in a very short period of time. So it is very easy. In addition to that, if you want to do a more complicated system where you're doing multiple arrays or you're doing larger systems, there's 4 M10 suspension points on the side on a single plane. That makes it very easy for you to design an exoskeleton structure to mount these speakers. There's also M10 points at the back, so it gives a good flexibility for the integrator to do exactly what they want. You'll notice that the width of this speaker is exactly the same width as the subwoofer. And it's a square speaker. So you can mount a 60-40 rotated to 40-60 above a 60-40 if you want to. The 40-30 is the same size. You can have 40-30 or 30-40. You can then mount it with a subwoofer or two subwoofers underneath or above, or you can mount the subwoofers at the side, and you can array horizontally and vertically. So with these very simple suspension points, you can make any configuration you want to with a relatively simple structure to support it.
Well, certainly we've kept installers, integrators, and consultants in mind when developing this product. What design tools are available?
Okay, well, the fastest way to get your acoustic design, the fastest and most accurate way to get your acoustic design is to use Preview EV prediction software. That allows you to not only predict the acoustic field, but you can also calculate your time delays and do any subwoofer integration. We also supply 2D AutoCAD, 3D AutoCAD, 3D step files, and BIM compatible files, so you can do a full 3D design. This allows people to build the arrays in 3D space so they can make proposals. And what we're finding increasingly is people will do a quick design in Preview to work out exactly what they want. Then they'll transfer the data to Ease, because that's the industry standard software, so that they can then make their proposal for the sound system and win that vital business. So we also provide GLLs for Ease, and it will work on the full Ease system. And we also have an Ease Focus license for that, so you can do a quick design on Ease Focus.
The other thing we should mention is that MTS is supported by SONICUE sound system software from Dynacord. So that means that once it's designed and installed, you have a pretty straight ahead way to monitor and control the system when it's in operation.
All right. Well, if there's anything else, I don't know if you guys have anything else to add before we wrap it up here.
Well, probably the most important part.
Yeah, well, what we missed out is that it's great having hundreds of dB SPLs and perfect dispersion, all that kind of stuff. This thing sounds amazing. It goes all the way up to the high frequencies. It's standalone. There's plentiful bass. It will make you dance. And I always liken it to something like a Ferrari, where you've got your maximum SPL, where you can drive a Ferrari at 180 miles an hour, and sure, you'll get loads of thrills out of that. But normally, you're likely to drive it up to 100 miles an hour, and it'll feel sweet and beautiful, and it'll just give you a great experience.
Well said, Andy. Well, thank you all for joining us. If you are looking for more information on MTS, please visit our website at electrovoice.com or reach out to your local sales manager. Thanks for joining.
Thanks, everyone.
Thanks very much.